In this video, I'm going to share or discuss another application of the definite integral. Okay, this is about the centroid of a solid of revolution. So, how are we going to determine or locate the centroid of a solid of revolution? Okay, let's have this one. The coordinates of the center of gravity of a solid of revolution are obtained by taking the moment of an elementary disk about the coordinate axis and then summing over all such disks. Each sum is then approximately equal to the moment of the total volume taken as acting at the center of gravity. And again, as the disk thickness approaches zero, the sums become integrals. Now, this is analogous to locating the centroid of a plane area. So if you recall, sa centroid of a plane area, we also took the moment of the differential or the rectangular element about the x and y axis, and then we sum up. Okay? So this is similar to centroid of a plane area, but this time volume. Okay. So for example, we have this figure, and okay, the region is revolved about the x-axis, and you will have this one. So from a vertical rectangle, pag revolve niya, you will get this disk. So sa solid of revolution, each disk, kuhaan yung moment. Okay? So like this example, this one, another disk, you also have another disk, no? So each disk na siya distance na x to the y-axis, di ba? So, this one, like for example, this disk, nasa distance na x referred sa y-axis. So, all we have to do is get the moment of this disk together with the other disk, sum up nimo. Okay? By summing over all such disks. So, we have this one. Moment about y, this time it's volume. Before, sa plane areas, as centroid of a plane area sa nisa, no? Pero karon volume na. No? So this one, equated na siya, each sum is then approximately equal to the moment of the total volume taken as acting at the center of gravity. So equate natin ni siya sa this one. Volume total times x bar. And so we solve for x bar, we have this. And sa last statement, kabut lang, no? It is written here, as the disk thickness approaches zero, the sums become integral. So we can replace this one by integral sign from lower limit to upper limit. Same sa area. Okay. And you can do the same sa y bar. So sum up moment about x, we have this equated na to, and we solve for y bar. Now, since this is already a solid, so it involves three axes na. Nanate z-axis ani. Z-axis is perpendicular to the xy plane. And due to symmetry, if you consider the solid, due to symmetry, z bar is equal to 0. Okay, z bar is equal to 0 due to symmetry. Always na siya. Okay. Okay. So, suppose we have this one. Okay. A line and then y-axis and another line, horizontal line. So this is the bounded region. Okay. And we want to revolve this one. I mean, these are the formula. No? Kung integral na, this time volume na. Sa previous topic area to. So this one is volume. Volume total x bar equal to x VL times dV and also for y bar. Z bar is 0 na. Okay. Always due to symmetry. Now, if you want to revolve this area about the x-axis, of course, we'll analyze a rectangular strip so that we will know our elementary na solid, no? Whether it will be a circular disc, a circular ring, or a cylindrical shell. Oh, if you will analyze a vertical strip, you will have this one. Okay. Now, for this one, this is x sub EL is x coordinate sa centroid sa element. Now, this time, kay solid naman eh. So, ang atong element, the element is already this one. It's no longer a rectangle. Okay. But this one, circular ring. So, where's the centroid located? Of course, here. And from this point to the y-axis, that will be our x sub EL. This one, x sub EL. And z bar is, again, is always equal to 0. Now, our y bar is 0 also because ang distance sa centroid from the x-axis is 0 man. So, y bar is 0. Bisa nasa ka. Okay? Whatever rectangle you will analyze, no? At a certain distance from y, pag-revolve sa x-axis sana, ang centroid sa washer will always be along the x-axis. Okay? So, y bar is equal to 0. So, ang isolve na to there is only x bar. Mawala ang isolve na to. Okay, x bar. Okay. Now, what if kung i-revolve na to sa vertical axis? This one. Let us say, we are going to revolve this region about the line x equal to a. Revolve na to. So, considering this element, rectangular element, pag revolve na, we will have a cylindrical shell. This one. Okay. Cylindrical shell. Now, this will now be our element. Okay? Dili na ang rectangle, kundi ang kining cylindrical shell. So if you will look at the centroid of this elementary na cylindrical shell, dali, no? Adi ang centroid. So, ang distance na centroid to the y-axis is our x sub EL, and the distance of this centroid to the x-axis will be our y sub EL. Okay. Na dire, wala na to. Okay. I did not put y sub EL because as we can see, y sub EL is 0 man. So, okay. Now, if you look at this one, okay, again, x bar equal to 0. Now, it's obvious na x sub EL will always be equal to A. Okay? So, even if we have a smaller cylindrical shell or a bigger cylindrical shell, the center of the shell will always be along this line, x equal to A. Okay. So, maski pagdako ng imong shell, diri gid yang center. So, our x sub EL will always be equal to A. And, okay, we will only solve for y sub EL, or y bar, sorry. Our x bar will always be equal to A. Y bar will always y bar is our unknown. So, para you will not get confused, I will give you a technique or a shortcut. Okay, no, a technique lang. No, not a shortcut, a technique. So the technique is this. If the region or if the region is revolved about a horizontal axis ha, it's either x bar or y equal to 2, y equal to 5, y equal to -3, or some other line, some other horizontal line. Basta horizontal line, you will only solve for x bar. Pag horizontal line, x bar. How about y bar? Eh, ang y bar is y value ato na line. Example, okay. If this area is revolved, not sa x-axis, but i-revolve mo siya about the line y equal to -2. Y equal to -2. Therefore, our y bar will be -2. Because y equal to -2 will be the kining center sa atong circular ring. Y equal to -2. So y bar is equal to -2. And x bar lang isolve. Kay horizontal man ang axis. Pero if the area is revolved about a vertical axis, y bar sa ang anon. Vertical, y bar ang anon. X bar is kung unsa ang x ana niya, mo sa ang x bar. Again, if this region is revolved about the line x equal to 10, our x bar is equal to 10. X equal to 10, meaning x equal to 10 is a vertical line. Vertical, ha? So y bar ang anon. X bar is equal to 10. Ana. So, even if ang formula dire is duha, solving for x bar and y bar, you will only solve one coordinate. The other coordinate can be solved already or can be determined already. Z bar will always be equal to 0. Okay? So, to apply this one, let us solve a sample problem. Find the centroid of the solid of revolution generated by revolving the given region bounded by y equal to x cubed, x equal to 2, and the x-axis about the line x equal to 2. Okay? So, let us graph the curves. Y equal to x cubed. This one. Y equal to x cubed. If you are not sure about this, you can substitute any values of x and then solve for y and then just connect the points. And for sure you will have this graph. X equal to 2 is a vertical line. X-axis, this one. So this is our bounded region. And it revolves just how x equal to 2. So vertical line, ba? X equal to 2 is a vertical line. So therefore, we will only solve for y bar. Y bar lang. Okay. And then our x bar is equal to 2. Z bar equal to 0. Okay. So, we'll solve for y bar. So, but before that, same with area, of course, we'll analyze a rectangular strip. It's up to you whether you analyze a horizontal strip so that when the strip is revolved about x equal to 2, you will get a circular disc or okay, or a vertical strip. Depende sa imo. Okay? Pwede na sa vertical strip. Pag revolve, you'll get a hollow cylindrical shell. But for this one, let's analyze a horizontal strip. Okay? So, label x left, y left. This one, x right, y right. Pero, we all know that x is equal to 2. So, we can just label this point as 2, y right. Okay? Instead of x right, we just put 2. Okay? Kay constant one dyan. And this is dy. And the length of our strip is 2 minus x sub EL. So, pag revolve, then ang radius na to is 2 minus x sub EL. So first, we get the volume. We solve for the volume. So circular disk man. So volume circular disk is 1 pi r squared times thickness. So our radius is 2 minus x sub EL squared niya dy. Now, pag integrate, we need the limits. So ang limits na to, the point of intersection 0, 0, and then this one, this point. Now we are sure about the x coordinate, which is 2. And substitute na to when x is 2, y is equal to 8. So, 2, 8 siya. And then our x sa BL, we replace x by y. X is equal to y raised to 1/3. And we have this. X equal to y raised to 1/3. So substitute na to there. Not the expression sa B. So to integrate, first you expand this one and then use power rule and evaluate sa lower and upper limits and we get the volume. So this is the expansion and then use power rule and then evaluate and this is the volume 16 over 5 pi. So again, we only solve for y bar kay vertical axis man. Our x bar is 2, z bar equal to 0. So we solve for y bar and this is the formula. Our V total is this 16 over 5 pi. Our y sub EL, okay. Our y sub EL is equal to y lang, okay? Okay, considering this strip, this disk, ang centroid niya is na dali, no? So, ang distance ani na centroid from the x-axis, y sub EL is y lang. Okay? Because y sub L and y sub R are equal. So, our y sub EL is same as y sub L or y sub R or simply y. So y lang. So our dv is this, the simplified form. dv, this one, dv, this is the simplified one. And we substitute this one here and we just include y. No? Ang y sub BL na to y. And then the rest is dv na pi times this times dy. Para shortcut na. So before you integrate, i-distribute sa ang y sa each term. Okay. So dito na. 4 times y dy, it's 4y squared over 2. So makancel 2y squared. Y times y 1/3 raised to 1/3 is y raised to 4/3. No. Integrate plus 1. That's 7 over 3 over 7 over 3. Or get the reciprocal 3 over 7 times 4. That's 12 over 7. And then this one, y times y raised to 2/3, that's 5/3. Integrate plus 1, 8 over 3, over 8 over 3, reciprocal, that's 3/8. And then evaluate from 0 to 8. And then simplify, equate sa left side. Cancel ang pi. And then you can solve for y bar. Okay, so that's it. So sa solid of revolution, we only solve for one coordinate. Okay, the other two coordinates can be determined directly. Okay, so this is similar sa area. ang devil lang, it will depend sa strip name. It will depend sa strip. Pero, based on experience, I would like to suggest na one, kinay if the axis is one, vertical, strip will be horizontal. Okay. The reason is, there, we all know, sa centroid ba? Sa centroid sa area na, oh, ang y sub EL or x sub EL could be the average ba? Could be the average. Oh. Pero kung, like this one, okay. If you will analyze a vertical strip, and i-revolve mo, you will get a cylindrical shell. Now, the centroid of the strip is average man sa y up and y down. So, ma-complicated ang imong y bar kay you will have a longer solution kay average man y up plus y down over 2 ba. Pero kung perpendicular ang strip, perpendicular siya, and your y sa BL is only y lang. So, mas simple siya i-compare sa kung parallel ang strip, rectangular strip sa axis. Similarly, pag ang axis of revolution is horizontal, vertical po dang kon. Vertical sa dang strip. Anyway, we'll solve more problems about this topic para you can understand fully this. So, I hope that you were able to understand the topic. Thank you for watching.